Find the derivative of this function here, y equals the quantity x cubed plus 6x plus 9 squared divided by x to the 2/3. And it looks like we should use quotient rule, but I always think it's a little bit easier if we can use the product rule. And so I'm just going to rewrite this so that we get x to the negative 2/3 times x cubed plus 6x plus 9 squared. Again, there's nothing wrong with using the quotient rule. It's just a preference of mine. I just think it's a little bit easier when it comes to simplifying your answer. And so to find the derivative, we're going to use the product rule. But our second piece here, when we have to take the derivative of x cubed plus 6x plus 9 squared, we're going to have to use the chain rule. And so our derivative, y prime, is going to be my first function, so x to the negative 2/3, times the derivative of x cubed plus 6x plus 9 squared. And so I'm going to get 2 times the inside plus 6x plus 9. I'm going to drop my exponent by 1 times now the derivative of the inside here, which is 3x squared plus 6. To that, I'm going to add my second function, x cubed plus 6x plus 9 squared, times the derivative of the first function. So the derivative of x to the negative 2/3 is negative 2/3, x to the negative 5/3. And so that is the derivative. Now we need to use algebra to simplify it so that it's one nice function. And so to do that, I'm going to first write everything with positive exponents. And so x to the negative 2/3 is going to move to the denominator. So plus 9, 3x squared plus 6. And that's going to be all over x to the 2/3. And then on this side, it's actually going to be a minus right? So this minus comes from this negative 2 here. I'm going to have a 3. X to the negative 5/3 moves to the bottom and becomes 5/3. And so that's going to leave me with a 2 x cubed plus 6x plus 9 squared. Okay? And so now, to simplify it further, we need to find a common denominator. And so I would need a 3. And then when I look at x to the 2/3 and x to the 5/3, the higher one is x to the 5/3. And so that's going to be my common denominator. Now to get that, looking here, I need to add a 3, which means I need to multiply my numerator by 3. And then to get x to the 2/3 to x to the 5/3, I added an x to the 3/3. Well, that's just one x, so I need to also multiply the top by an x. And so now my numerator will be 3 times 2x, x cubed plus 6x plus 9 times 3x squared plus 6 minus 2 times x cubed plus 6x plus 9. And when you see this, you're going to have a good intention to try to simplify this by distributing, multiplying out this trinomial and binomial, but you don't want to do that. You always want to factor, okay? And so when I look at what we have here, I see a 2 and a 2, so I'm going to factor that out. And so we're done with those. I also see an x cubed plus 6x plus 9. I see an x cubed plus 6x plus 9. So I'm going to factor that out as well. So that gives me x cubed plus 6x plus 9. And so this factor disappears, and one of these factors disappears. That's going to leave me with 3 times 3x squared plus 6 minus, now all these signs are going to change, x cubed minus 6x minus 9. and that's all divided by 3x to the 5/3. And so all we need to do now is simplify 2x cubed plus 6x plus 9. Over here, this piece here will become 9x squared plus 18. And so I'm going to have a negative x cubed backtrack. I also forgot this x here, and so this is actually a 3x. And so 9x squared plus 18 is actually going to become 9x cubed plus 18x. Okay, and so when we simplify here, let's try that again now. We'll have 9x cubed minus x cubed, which gives me 8x cubed. And so we're done with those. We have 18x minus 6x, which is plus 12x. Those are done. And then we're going to have a minus 9. And that's all divided by 3x to the 5/3. And there you have it. There's the derivative. Again, here's the calc piece, and then here is the algebra.